You ready? Okay. So what we're gonna do next is we're gonna create a lesson. So if there was more people, we would have had you guys pair up and then share with the audience, or with each other, right? But since there's not, we're gonna pretend that we have an audience, and I can be one of your students. But you're gonna get to just review every single topic separately.
Can I use a book?
Yes, you can use a book. And I have your problems here. So we have 4 different types of problems. So do you want to review the rules? Or actually, review the topics that you'll be covering? So what are the topics?
Factor and reducing polynomial fractions, add and subtract polynomial fractions, multiply and divide polynomial fractions. And then why did I group add or subtract and multiply and divide?
Yeah, that's just a question.
Oh.
But before we get to that question, so can you identify on this board which one is going to be factor and reduce polynomial fractions? So that you know which problem to put on each paper?
Would be that one. And that one.
Well, only one is asking you to factor and reduce. So there's one. Yeah.
So this one?
Yes. What about the add and subtract one? Which one's that one? Or okay. And then multiply, divide. Okay. And then I guess I forgot to put solve. Okay, and then solving. Okay. And when you're solving, what's going to be your goal?
To get n by itself.
Yeah, good job. Same thing as solving any other equation. Okay, and this is something just to keep in mind. We'll talk about this later. Okay, so what are your rules?
Show every step, write out detailed steps, put in one Socratic question for the audience, be neat, be creative. And we have 15 to 20 minutes.
Yeah, so it was going to be 15 to 20 minutes to work on it, like as a group, and then everybody would present afterwards, but you could just take like 15 minutes for each one, that's fine. If you take the whole session, that's fine. What was I going to mention? Oh, do you understand what a Socratic question is? We've talked about it before.
I usually ask them.
Yeah. Okay, so once you do present them to me, make sure you input your Socratic question.
Okay.
To make sure that I understand, because I'm gonna not understand anything. Yeah, and make sure you put like the title of the topic that you're covering.
Okay.
So reducing polynomial fractions, and then your problem.
So do you want me to use these problems?
Mhm.
Okay.
Yeah, and I also put an extra problem in case you guys were finished early, but
Okay.
it's just you, so
Okay.
we can work on the extra problems after if you want to. Do you want me to time you? So you know how you're doing on time? Where's my phone? Okay. 15 minutes.
Oops. This is pretend not to go on there.
God, man.
I thought it was paper. It's okay. It came off.
Okay.
It's all good. It's okay.
That didn't happen. That was not caught on camera.
Okay.
So first write your problem down. Wait. Which one did you say was reducing?
Oh. I was looking at one. I can't think today. I'm really sorry.
I like how you stopped yourself though on what you were gonna say.
You gave me a hard one.
You can do it. You could do it, put your brain into it. Also, do you have your factoring flowchart? That's
Yeah.
always helpful.
I kind of like almost memorized it. So
Oh,
it's okay.
awesome.
So,
Good job, Amanda. You're being very detailed.
oops.
I have a question.
Mm.
So if, I'm not saying this is wrong at all, but if you had wanted this, in this right here to stay positive, what would you have done instead?
Put positive. I mean, add it.
So if you wanted this to remain, so originally it's positive and it became negative. Why did it become negative?
Because a negative times negative is positive.
Right. So if you had wanted it to stay positive, what would you have taken out?
Negative. I'm confused.
So, okay, so say you had wanted this to be r plus 2, not r minus 2, what number would you have taken out instead of negative 4?
4.
Yeah, cool. That's just a conceptual question. We could touch on that later.
Okay.
But good job so far. I won't tell you if you're right or wrong.
Okay.
Although you're being very thorough, so I'm sure you know.
Oops.
Question.
Yeah.
What are you doing right now?
I'm going to do the difference of two squares
Why did you take the 2 out?
to factor it.
Can you explain how you took the 2 out?
I'm multiplying the 2 into the r squared for, 4. Wait, no.
Oh, that makes sense.
So then that's
And what is this called?
difference of two squares.
Nice. And then we just abandoned him?
No.
Good job.
What would you call this? Would you call this, it's not an equation, would this be an expression?
Mm-hmm. Good job. Yeah, there's only 2 types of math sentences, so the equation or the expression. And don't forget that you need to have a Socratic question in there somewhere for me,
Okay.
for the audience. For our viewers at home. You didn't get on time, you have 6 minutes, so you'll be ahead of that time. That's good. So, one question, why did you hesitate to circle it? What were you doing in your head?
I was making sure that it's reduced all the way.
Okay, good job.
So, you said that we had to ask a Socratic question. Do we do that when I'm gonna like teach you? Or
Yeah.
I do it on here?
You can put it on there, or you can have it in your mind, however you want to do it. So you see how I put my Socratic questions like up so that I can remember to ask you guys. You could do it there, or you can just have it in your head, however you feel comfortable.
Okay. Let me think. I'll probably just ask it later.
Okay. So whenever we're adding and subtracting any type of fraction, what do we need to have? Adding and subtracting fractions.
You have to have a addition thing. Sign.
Yes, or a subtraction sign, because that's how you add or subtract. Let's see. Let's start it off, and then we'll see. We'll keep that question in mind.
Okay.
Well, what are you thinking right now?
And how to write the rule.
What's the rule that you're thinking to write?
Since this part's already factored, we want to factor the second. Would that be an expression or
Well,
fraction?
this is a fraction. However, when you're adding or subtracting fractions, there's something that you always need to start with.
GCF.
Not the GCF. It's close though. It's something that we get confused with GCF.
LCD.
Yes, the LCD. So remember that we weren't gonna go. You came up with it right here. Find LCD, and I said we're not gonna really cover that individually, but we're gonna have to do it either way. So this is where we do it now.
So that would be the first rule.
The first step. What do you think?
Yeah.
Okay.
Oh yeah, that's right. Sorry.
That's okay. Oh, let me put the timer again. You're quick at identifying those now.
Yep.
Good job.
Would I have to multiply the line by -7? Or do I leave it?
What do you think? What's making you question that?
I don't know, I feel like I need to, but I'm not sure.
Okay, so normally when you have fractions and you make the denominators the same, what do you do?
Then you add the numerators.
Okay, so let's do that and then see if we have to do that after.
Okay.
Okay, so now that this is all together, what rule do we have with dealing for expressions that look like this? With multiplication and division. Not yet, right? Because we don't have, grouping is when we are factoring, right? And right now we don't have an exponent on anything, so we're not factoring yet. But look, we have multiplication with parentheses inside, and then we have addition and subtraction.
You need to do PEMDAS.
PEMDAS, yeah. So would it have mattered if you did PEMDAS here and then added these together?
It would be the same thing.
Okay. I love how you guys are so good at talking like with your math terminology now. Just go home and smile about it all day. Yeah, I'm sure. Although, I'm sure. We have 9 minutes. Just write it on the paper, your options, if you have to, if you're doing it in your head.
I'm trying to think of multiple. Oh. My God, I'm an idiot.
No, Amanda, don't say that. Now you have to say, I'm smart. You can't say those negative things to yourself.
I'm sorry.
Amanda is smart. Look at all this great work. Yay. If you weren't smart, you would have just stopped here. But no, you knew that you had to keep going. Okay.
Good job. Wait, is the top part green or black?
What do you mean?
The ink.
Oh, I
Because
think it's
if
black.
I look close, it looks green. Like a dark green.
Maybe. I don't know.
Looks
Looks
it's
black to
throwing
me.
me off.
Okay.
The screen turned off.
Before we move forward, Why did I put add and subtract together? Like, why aren't we doing like one add one and one subtract one?
Because technically you're adding and subtracting in the whole thing.
Okay, but what if this one had been a subtraction sign instead of add? What would be like the key similarities? So why that these are together? Like, what's the key thing that makes these be together in one group and multiplication and division be in its own group?
Because the signs change.
The signs change? What do you mean?
Like, say if this was a negative, you'd have to multiply that by -1.
Okay.
So then that makes the signs change.
Okay. But what's something that always happens when you add and subtract fractions that you don't have to do when you multiply and divide?
Oh, you have to find common denominator.
Right, yeah. So that's why we have them together.
Because on this one you could just cancel. You don't have to have a common denominator.
Right. So the steps would be pretty similar, except it would be like subtract numerators, right? Cool. Coolio. And look, I gave you two. You can choose either option.
Okay.
They both look fun. What's the word? Use the word.
Well, the reciprocal.
Right, yeah.
I want to make sure I'm not going to write on the board.
What does that say? Factor what?
Oh, sorry.
Wait,
I'm so used to writing.
No, I just can't read it. Oh, this says factor out.
Yeah.
Factor out LCD. What do you mean least common denominator? What do you mean?
You confused me, I thought.
Just because I asked you a question doesn't mean that you're wrong. I just couldn't tell what it said.
What did you think it said?
Alt? Factor alt? And I was confused.
4 can't go in a 25, right?
You tell me. I'm pretty sure you know the answer. You can check it on your calculator if you want to.
No, I'm just thinking what I need to do.
So normally, when you do difference of squares, you always identify A and B, right? I've seen you doing that.
I have to divide, right? Divide by 4. Well, because I want to get the x by itself.
Right. Well, not really. You don't have to get the x by itself. But let's see right here, right? This is a difference of squares, right? And you think this is a difference of squares, right? You're trying to figure that out. Right here, you identified A and B. Which one is A and which one is B here?
Y is A and the negative 7 is B. Squared.
Not the negative 7.
Oh, 7 squared.
Just a 7. Okay, so a question. Is 7 squared B or is 7 squared B squared? Which one is it?
B squared.
Yes, so then which one's B? Which part's B?
The 7.
Yes. So you've been doing that. I see that you've been doing that everywhere, where you identify, like this is A, this is B, right? So here you identified that. Which one is A again and which is B again?
The Y and then 7.
Okay. So what's in front of this Y right now?
A 1.
The 1. So technically, what's A in total? Including what I just said is in front of the Y.
1y squared.
Just A by itself. What's
Oh,
A by
Y.
itself? Is the 1 included with the Y?
B1.
And is that included as part of A? 1Y? Yes. Okay. So if we look at this one, what can we identify as B? What do we know as B?
25.
Not 25 yet, right? Right here, B is not 49, right? So what's B?
5.
5, okay. Now what's A?
2x.
Yeah. How did you get that?
Because I'm taking the square root of 4.
Mm-hmm.
X squared.
Yeah, good job. So it's the same thing, A and B. Just that now our coefficient's not 1.
Right? So this is how I would write it.
I don't know, write it out and see if it makes sense once you write it. You tell me. So that would be A minus B, right? Is that A? Is that what you decided is A? How about, okay, right here, write A. So what did you decide is A, that A equals to?
4x squared. Well, 4x.
So let's go back to this example. A is not y squared, right? What is A here?
1y.
1y, just by, not the squared yet, right? So then what would A be here?
4x.
4 is also already something squared, right? You showed it here.
I'm so confused now.
Yeah, I could tell. Let's see, let's work through this together. Okay. Okay, so I like how right here you showed what equals A, what equals B, and what equals C, right? So we need to keep thinking in terms of A and B, because the formula for difference of squares, can you show me, let's just do like a little, the difference of squares, okay? And you call it the difference of two squares, so I'll just call it like that. So the formula for difference of squares, if you have A squared minus, forget that, B squared, what do you end up having? Can you write the rest?
It'd be A minus B. Right?
Mm-hmm. And then? Yeah. So before you get to here, though, what do we have to identify? We have to find out what?
What A and B is?
Yeah, so we could put A equals right here and B equals and just have like, leave it blank, but put that there as like steps. Okay, so when we did this one, y squared minus 49, what did we say a equals? You can write it up here in the green if you want.
1y.
Okay. What's b?
7 squared.
Is b, okay, so back to here. When we have b, we just put the square root version of it, not the squared, right? So we're not trying to get the square, we're just trying to get the b by itself.
So 7.
Yeah. Okay, so keeping this in mind, that's what we put in here, right? We don't, b is not 7 squared. A is not y squared. It's just what you have here. So now we gotta go back and do it with this more complicated one, which is 4x squared minus 25.
So then a is 4, right?
Well, so a difference of squares means that both of these are going to be a number squared. So what number is this squared?
2x.
Yeah, it's 2x, so you need to put the 2. Because this is really the same thing as 2 what?
2 times 2.
Right, 2 times 2, which is the same as 2 squared. So that's why it's a difference of squares. That's 2 squared and x squared. So yeah, so then a would equal what?
2x.
Yes.
And then b is 5.
Yes. So what about this is confusing you?
I don't know, I wasn't thinking, I think.
Or are you just thinking too hard? We've been working on math for a long time.
I'm probably overthinking.
It's okay. So just when you go home, kind of think about a difference of squares when you have a coefficient in the front. And then we can, if you have more questions or trouble, then just like either me text Jamal or them, see if they can help you. Because me and Jamal worked on this a lot too, the last SI session. Or you can always ask me. Okay. So now you know, I mean, based off what we wrote here, what you have to do next. And you know, because you've been doing it.
Okay, yeah, that's right.
Don't forget you're writing your steps too, like what you were doing. You got 6 minutes.
Okay.
That part's so satisfying, huh?
Yeah.
Awesome.
And then what's the fourth one for?
Oh, the fourth one is solving. So just solve. That's what it's wanted to do. Solve polynomial fractions. So I do want you to take notice of something though. In all of these, which ones are expressions and which ones are equations?
This one's the only equation.
Okay.
The rest are expression.
And have we encountered this problem yet? a restricted value. Did you see that we had any values that we were not allowed to have here?
I don't think so.
No, right? We haven't encountered it. So that means that it's coming up now. Okay? It's almost time for my lecture.
I think this is the one where I missed class because I don't remember doing this.
Okay, that's fine. So since you weren't there, we're probably gonna have to reference the book. But beforehand, we have to think about a concept that we haven't thought about in a while. But what happens when you divide a number by, or what happens if you do 0 divided by 2? What's your answer?
0.
Okay, what if you do 2 divided by 0?
It's undefined.
Undefined. So is it possible that there's some number that what number, if you had it, if n was some number, what number would make this undefined? Would make this fraction undefined?
0.
So if n was 0, it would be undefined?
6. Or negative 6.
Yeah, right? Why?
Because negative 6 plus 6 is 0.
0, yeah. So that means that in our real world that we live in right now, that could never happen. N could never be negative 6. That wouldn't make sense. It would be undefined. So how does that answer that question? What is a restricted value?
Dividing anything by 0.
Dividing anything by 0 is what? What did you just say it was?
Undefined.
It's undefined. So then our restricted value in this problem is going to be what?
Negative 6.
Mm-hmm. So you always keep that in mind with solving polynomials. So you can write that here, like n cannot equal negative 6. You're just letting yourself know that cannot happen. If that happens, that's just bad news. Okay. Do you know how to write that like as a math sentence without using the word cannot? When something does not equal something?
Oh.
Cool. Yep. Okay.
So then
So how do you solve any equation in general? You said it earlier. We talked about it earlier.
well, if they both have the same denominator, don't you just have to do the top?
What would be the point of that? What do you mean?
Wouldn't you have to subtract the 1 on both sides
And why would you do that?
to get this one by itself?
Okay, so you're saying you want to get n by itself, right? Isolate the variable. So that's really good that you know that you need to do that. Except you notice, we do have a denominator, right? And they are the same, which just seems like that would be helpful. But we have to do something about that. We can't just add them up and ignore the denominator. Okay? So, since you weren't in class, I think we have to reference the book. So, is that your book?
Mm-hmm.
Okay, so let's look for that section. So, solving polynomials.
This one's simplifying. Multiplying. Subtracting. Simplifying complex.
And as soon as we see equations, we know like we're in a good area, right? Because you said that's the only area that has equations. Let me time this section. Okay.
Yeah, this is the one that I didn't. I
Okay.
wasn't here for.
So let's see what it
So
says to
like
do.
something like this one.
Mm-hmm. Well, look, there's steps right here. So do you want to, let's see. Do you want to read the steps and review this problem and see if that helps?
Okay.
And I'm here if you have questions, you can ask me.
See, because I know how to do this with like different denominators. I remember how to do that, but with the same denominators, I'm not sure.
Well, let's see, what does step 1 say to do?
If possible, factor all denominators.
Okay, so is that possible there, or is it already done?
It's already done.
Okay, so then let's move to step 2.
Write down the LCD of all the expressions.
Okay. So what would the LCD be here?
N plus 6.
So it just says write it down, right? So. Okay. Okay, now what does it say? I can just hold it for you if you want.
Okay.
So we don't have to go back and forth.
Yeah.
Okay. So what? Number 3.
Multiply both sides of the equation by the LCD to eliminate the denominators.
Okay. So what's our goal in this step, in step 3?
Multiply n plus 6 throughout the entire equation
But why?
to eliminate the denominators.
Yeah. So that's our goal. Eliminate denominators. Sounds like they're evil. Eliminate the denominators. Take them down. But look, you could see in the book. So
Yeah.
right here, the LCD is
16 to.
yeah, and they multiplied it by everything.
Yeah.
Cool.
And then we multiply this one by n plus 6 too.
What does it say? Does it say everything or just saying what is it? Well, what is it doing in the example?
Sides of the equation. So this would count, right?
You check the example and you tell me.
Yes.
Where do you see that happening? Yes. However, you put this like, oops, you put this over this. Does it have the, oh crud. Does it have the numerator and does it have it like as a fraction?
Oh no.
Yeah. And what's the reason why it doesn't have it like this? What was our goal again?
It's to put it over 1. We need to keep the same denominator. We don't want to change it.
No, well, this is our goal. Eliminate, remember? So we want only one of them so we can
Oh, right.
do that. Okay. So what's our next step?
Then we need to,
Oh,
like, eliminate.
okay. Go for it. The satisfying part. Yeah. You're going down. Are you checking your steps? Or do you just know what to do now?
I know what to do now.
Oh, okay. Okay, I'm sorry. Just throw this out.
And that's the answer.
Okay. And what would we do normally if we have an answer like this on the test?
We check it.
Yeah. So it's up to you if you want to do it or not. You're the one that's going to give me a lecture, so you can decide. Is this my copy?
That one's mine.
Oh, crap. Sorry.
Okay.
I put a fingerprint in it.
It's okay.
Okay. Good job on this. Good job. However, what you wrote here, is that the same as this? Is 1 times 12 over 1 the same as 12 over 12?
Yes.
1 times 12? Wasn't that just going to give you 12 over 1?
Well, I was just doing this.
Okay. Well, just make sure you write it right, because then on the test you have to go back and check your work.
Okay.
We're mathematicians here. Okay. So is it right?
Mhm.
Okay, cool. What would have happened then if it had been negative 6?
It would have been undefined.
Yeah. Good job. Okay, are you ready to lecture me?
Okay.
Don't forget that you have to ask me a Socratic question.
Okay. So the first thing that we're going to learn today is factor and reducing polynomial fractions. And this is an example here. Now the first thing that you want to do is always see if there's a GCF. Do you see any GCFs here of the numerator?
They
Just
both have an
focus-
8. Oh, and the numerator?
Just in the numerator.
No.
And then, is there a GCF in the denominator?
Yeah.
Which is,
2.
okay. So, you want to factor out the GCF. So, you want to write down 2, and then, how will you get the r squared minus 8?
Oh, yeah, you make it into a 4.
So it would be r squared minus 4. And then we're going to stop there for a second. We're going to go back to the numerator. Since there's no GCF in the numerator, we have to do the AC grouping method. So A equals 3, B equals negative 10, and C equals 8. So what they mean by AC grouping is you're multiplying the A and the C together. So 3 times 8 is 24. And then you want to factor using the magic 8 method. So you're going to take the 24, and then you're going to take the negative 10. So then you have to find two numbers that multiply to 24 and add to negative 10, which are negative 6 and negative 4. Then you want to group that. So you're going to take 3r squared minus 6r and minus 4r plus 8. You don't put the negative 10 because you're grouping. But negative 6 and negative 4 is a negative 10.
Oh, that's why it works.
So then
Awesome.
after you group them, you want to find the GCF for both. The GCF here is 3r, and the GCF here is negative 4. So then you want to multiply this by 3r. So you have 3r times r minus 2 plus negative 4r, negative 4 times r minus 2. So then what you have left over is you're going to take the 3r minus 4, and then you're going to take the GCF, which is r minus 2. And then we're going to come back here to our denominator, and you have a difference of 2 squares. So r squared minus 2 squared is r squared minus 4, which we have up here. And then you want to factor them all the way through. So we have the 2, we have to bring down the 2, we can't forget the 2. And then we have r minus 2 times r plus 2, because it'll give us this answer here if you go back and FOIL. Then we want to rewrite the expression or the fraction.
It's an expression.
And
I mean, I think I'm just a
this
student.
was the answer we got for the numerator, and this one's for the denominator. So you want to put the 3r minus 4 times r minus 2 on top, and then the 2 times r minus 2 plus times r plus 2. And then you're going to cancel out anything that can, which are the r minus 2's. So what you have left over is 3r minus 4 and 2 times r plus 2. And you can't reduce on this one. So that's the final answer.
Great. Taking notes.
Next, we're going to work on adding and subtracting polynomial fractions. When you add and subtract fractions, you always have to find the least common denominator, or else you can't do anything. So this fraction's already factored all the way through and has its LCD. This one, we need to find the LCD, and right here is the difference of 2 squares. So y squared minus 49 ends up becoming y squared minus 7 squared, because 7 squared is 49. And then you just want to factor it completely by putting y minus 7 times y plus 7. And so I rewrote the equation, and you want to bring both the GCFs all together. So what's the one thing that is missing on this side? That's
y minus 7.
So you're going to want to multiply this fraction by y minus 7. And when you do that, you get y times y minus 7 over y minus 7 times y plus 7. And then moving on to over here, we're going to add the second fraction. And you're going to get y times y minus 7 plus 10y minus 28 over y minus 7 times y plus 7. And so now you're going to want to
Wait, can't we just cancel out that y minus 7 on the top to the y minus 7 on the bottom?
you can, but it's better to take things step by step so you don't get yourself confused. So what I did here was...
I thought we couldn't because there's a plus sign, so we can't cancel these out yet. Can these be canceled out right now?
I would think so.
Oh, look, he has friends. He's hanging out. My unknowing student question failed me. No, we can't. Because look, remember we have order of operations first, right?
Oh, right.
We have to do all the addition and subtraction of parentheses first before we could do this stuff. So I'll ask again. Wait, can y minus 7 be canceled out on the top and the bottom?
No, because you have to do PEMDAS first.
Oh, yeah. Take notes.
Okay, so we're going to multiply this together. Y times y is y squared, and y times negative 7 is negative 7y. And then you just put the rest, bring it down. And then you're going to want to combine the like terms, since the y's are the only like terms. Negative 7y plus 10y is 3y. So we have y squared plus 3y minus 28.
So we're done.
No. After we get to here, we need to find the two numbers that can go into negative 28 and 3. And to do that, I suggest using the magic 8 method again, like we used over there. So the two numbers that can go into negative 28 and 3 would be 7 and negative 4, because 7 times negative 4 is negative 28, and 7 minus 4 is 3. So then you're going to want to write the y minus 7, y plus 7 and the y minus 4, and then you can cancel out.
Oh,
So you
now we
cancel
can
out your
cancel.
y plus 7s, and then the remaining is y minus 4 over y minus 7.
Good to know. Good to know. Notes.
Okay, so the next thing that we're working on is multiplying and dividing polynomial fractions.
That's just the same thing as the other one, right?
No, because with adding and subtracting, like I said earlier, you have to find the least common denominator. But with multiplying and dividing, you don't have to.
Oh.
So the first thing that you want to do is rewrite the second fraction as the reciprocal and then multiply. And reciprocal means just flipping over the fraction. So the 12x minus 30 is going to be on top, and the 4x squared minus 25 is on the bottom. So then, after that, you want to factor out the GCFs for everything. So 2x squared plus 5x, the GCF would be x, so we have x times 2x plus 5, and to check to make sure that's correct, you just multiply the x into them. X plus 4 is already factored. 12x minus 30 have a GCF of 6, so 6 times 2x minus 5, and then 4x squared minus 25. So it's the same thing, we have the difference of two squares, but we just have a number in front. So you want to take the square root of 4x squared, which is 2x, and the square root of 25 is 5. So it'd be 2x squared minus 5 squared.
Good
But
job.
then that's not factored all the way, so you have to factor it, which is 2x minus 5 times 2x plus 5, and to check to make sure that's correct, you just FOIL. And then after that, you want to factor and cancel. Nothing can be factored, so the only thing we can do is cancel. So the 2x plus 5 and the 2x plus 5 cancel out, and the 2x minus 5 times the 2x minus 5 cancels out. So the remaining would be 6x over x plus 4.
Good job.
And then last, we're going to be solving polynomial fractions. So we have n over n plus 6 plus 1 equals 18 over n plus 6. So we need to make sure that we don't come up with a restricted value, and by that I mean anything divided by 0 is always going to be undefined. So, for example, let's say n equals negative 6. If you plug in the negative 6 and add it to the 6, that's going to equal 0, but you can't divide n over 0, or because that's undefined. But if the 0 was on top, then you'd be able to. So we know that n cannot equal negative 6. So then what you want to do is find the LCD, which is already here for us, so the LCD is n plus 6. And then to eliminate the denominator, you need to multiply the entire equation by n plus 6. So we have n plus 6 times n over n plus 6 plus 1 times n plus 6 equals 18 over n plus 6 times n plus 6. And then you just cancel them out. So then what you have left is n plus 6 equals 18. And then you combine the like terms, which the only ones are the n's. So n plus n is 2n. Bring down the 6 equals 18. And then you just want to solve for n. So you subtract 6 from both sides, and you get 2n equals 12, and then you divide by 2 on both sides, and you get n equals 6. And that's your answer. And to make sure that you have your correct answer, you want to check it by plugging in the 6 into all the n's. So we have 6 over 6 plus 6 plus 1 equals 18 over 6 plus 6. So 6 plus 6 is 12, so we have 6 plus 12 plus 1 equals 18 over 6 plus 6, which is 12. And to be able to add this, you need to have the least common denominator like we did with adding and subtracting, since you're adding. So you want to multiply the 1 by 12 over 12. And so you get 6 over 12 plus 12 over 12. So if you add the top, which is 18, and you keep the bottom the same, so it's over 12, and so this is the correct answer because it's 18 over 12.
Yay! Good job. Although I think you forgot the Socratic question at the end, but that's fine. Quick tip. Definitely when you move on to the next math, you're going to have to be very careful when you have variables and you're inputting variables. So right here, what part is n? Which part was n where you plugged it in?
Here and here and here.
Yeah, so then you should always put parentheses where you're plugging in.
Oh, okay.
So let's do that here just for practice, for more of like a reminder. And then you can take them out in your next step, but you always want to start, because later on you're going to get into math where you have to put in so many variables, and this will mess you up. Even this right here is not technically right, because right now, what is a square hitting?
Both of them?
It should be hitting both of them, right? But the way you wrote it, what is it hitting?
Just the x.
So how would you write it so it's hitting both? Yep, and now it's right. And it could also be right here. And that's a variable thing, right? It's a minus b. So, awesome. Okay, let's see how much time we have left. So, yeah, we have a little bit of time. So what we were gonna do was gonna kind of review what could possibly be on the final. And the activity was gonna be like in pairs, you're gonna pick 2 problems, just any 2 problems from any past exam, and then work on them, work on the ones that the other pair picks. But since we don't have other people here, what we could do is you can just pick 2 problems and we can like work on them together. Or if you want, we can work on another one of the solving that's a little bit different. Because I know you said you had a little bit of problem with the solving. And we have a different, like this extra problem, it looks easier, but you end up getting 2 answers. So it's up to you what you want to do. Final exam practice, or do you want to practice more of the solving?
I'll do the exam one.
Okay. So then let's add the rules for that activity. Just not in pairs, I guess. Me and you could be a pair and then. Okay. So get a partner. Me. Pick 2 problems from past exams that seem challenging. So just 2. And then give 2 problems to ourselves. Discuss how you would approach this. And if we have time, work it out.
Okay. I actually did bad on this test, but since I got the extra credit, right, it like went up a lot.
Oh, this is just the last one?
Yeah.
Okay. So it could be any past exam. It doesn't have to be this one. But if you want to pick 2 from this one, that's fine.
I'll do this one because this is the one where.
Do you want to do it on the paper, or do you want to do it on this little board?
I can do it on a piece of paper.
Okay.
I just want to figure out which one that is.
Did you pick them up?
I picked one so far.
I have paper too if you need some.
Okay.
You want one?
No, thank you.
Okay. Which one did you choose?
14 and 20. See, it was the same thing that I did up there.
Oh yeah, you're right. I don't want to like breathe down your back, so maybe I'll work on it over here on a different piece of paper.
So you're working on it too?
Mm-hmm.
So the directions are factored completely.
I'm gonna let you take the lead on this since I didn't take that test, you know.
I don't know what I was thinking when I was doing this.
Oh yeah, good for step, good for step. Like Family Feud. Good job.
Yeah, like look what I did. I subtracted the 7 and 4 and the x's, even though I wasn't supposed to.
And that's all you had to do.
Because you don't have, I don't know what I was thinking because I'm not dividing. I don't have to, I can't subtract them.
Maybe you were just nervous?
No, I haven't been thinking clearly.
If you feel like this has been happening a lot where you feel like you haven't been thinking clearly, maybe because you're stressed, you should try some of the mindfulness exercises that we've done. Do you remember any of like the meditation or mindfulness things that we've done in SI session?
Mm-hmm.
Were you here for the 5 senses one?
Yeah,
Yeah. What did you think?
it was fine.
Yeah.
Like I wasn't nervous or anything. I don't know what was wrong with me.
But I know sometimes when you're stressed out, you may not feel like you may feel like you're dealing with it good, but you're actually it's coming out in ways like you just can't remember things, or you know, you start forgetting stuff, or you blank out on a test. So sometimes it's good to, even if you're here at the test and you're doing things but you feel a little stressed or you kind of forget, just stop, do some breathing exercises or do the 5 senses thing, and then keep going. Yeah, because stress, I've had that where I've literally been, it was like the final exam for a class, and factoring was like what we had done like the semester before, and I completely forgot how to factor, so I couldn't do anything. Like,
Oh dang.
yeah, and I just started crying at my desk. But if I had known, I would have like probably started to do more mindfulness techniques and stuff, you know?
Yeah.
So, but look at you. Look at you now.
I
Good
know,
job.
like I remember after I finished the test, I was just like, I don't remember anything. Which is weird because I've like been remembering everything so well. See here, I accidentally put it the other way around when I had to keep it like 5 minus x times.
Do you want to
5
try that
plus
one?
X. Well, I know the answer.
You do?
Yeah. Because I put this the wrong way. It wasn't supposed to be x minus 5 times x plus 5 because it was 25 minus x squared.
Yeah. You got excited.
Yep.
Do you want to try another one of these, or do you want to try another solving one then, since we still have a little extra time?
I guess we can try solving that one.
Okay. Because I have the problem right here. And this one is a little bit different. So just do the other solve one. Do you want to do it on your paper? Or do you
Yeah.
for this one? So I'm going to try not to tell you, give you any hints. Just use all the tools you have.
Okay.
Use all the rules you know. Think of your goals and stuff. You have your steps over there too that you just wrote for solving polynomials.
I feel like I did something wrong.
Why do you think you did something wrong?
Because don't I need to multiply the numerator and denominator by this?
So what was our goal of getting the LCD? There was a reason why we got the LCD and we wrote it up
So
there.
we can eliminate
So we can eliminate what?
the denominator?
Okay, so then did it work?
Yeah.
So then that step was good. So since we're solving right now, by the way, you didn't write that we're solving. That's important that we know what we're doing. So since we're solving, normally what do we have to do in order to solve?
Oh, wait. I think I got it.
You go, girl.
Then it was, like you said, solutions.
Okay, time's
Right.
out. Before we get a solution though, what do we always have to do with solving polynomials?
Check.
Look at that note that I wrote there. Remember?
The restricted value?
Yeah. Is there any restricted values here?
No.
So there's nothing here that would make the denominator 0?
It would be -2.
Yeah. So what's our restricted value?
-2.
Yeah, so we should write somewhere over here M about that as a reminder. Okay, so then now we can write our solution and we make sure that we don't get this.
Wow, I actually did that well.
Very nice, very nice. Yeah. How come you said that these were hard for you? Or that it seems like you do them really well.
Not when I was doing the test.
These were not on the test, were they?
Those two.
Where?
It was number 14 and
Oh, this is factor, not solve.
20. It says factor completely, and I wrote that.
But I'm saying for the solve ones, you said that these were challenging for you.
Oh, I thought you were pointing to these.
But it seems like you're doing good. So what about the solving ones confuses you?
I don't know.
Well, keep in mind that you can always take a picture of these boards too, since you wrote the rules for yourself. So if you want, take a picture so
Yeah,
you'll
I'll
have your
do
own
that.
rules. For our closing activity, because I think we're pretty much done. What was our closing activity? Oh, right. So let me pull up the slide. So for the closing activity, we're gonna take out the practice exam that we have.
Okay.
And we're gonna identify, well, I'll wait for you to take out the practice exam. So just identify what part of practice test 4 we reviewed today.
Okay.
So you just go through each problem and then I'll just be your partner and you can just tell me which parts you think we've gone over today.
We did something like number 4. We did
So conceptually, which problems?
The difference of two squares here.
Okay.
The reducing polynomial fractions.
Okay.
Adding and reducing. Dividing. Solving. And then identified the restricted values.
Cool. So we covered a lot.
Yeah.
We also did this one too.
We
Solve
did.
for x. That's just solving.
Oh, okay.
Just that we did the even harder version because we did it with
right.
fractions. So we did. This is like an easier elementary.
Definitely.
So we didn't really go over this stuff in detail, but pretty much need to know how to do that to do this. What about number 3? What do you think?
That's wrong because not every polynomial will factor.
And if it doesn't factor, what's it called? There's a place on campus called this. If something's unfactorable, like the number 13.
Oh, prime.
Yep. And if you're hungry, you can go to the prime cell. See?
That's
Okay. Do you have any lingering questions?
where's the LAC at?
The LAC? It's like, you know when you wait for the SI session to start, if you just keep going straight and then to the left, that's where the LAC is at.
Okay.
Yeah.
That's where I'm gonna meet you tomorrow.
Oh, yeah. You've never been there with me? Huh. Anyways, and that's also where you would apply to be an SI.
Okay.
Yep. And don't forget, if you want to take a picture of these. Also, you can take them home with you if you want. Put them in your room. I always tell you guys that.
I'll take pictures.
Javier took it last time though. I think he put it in
he
his
did.
room.
That's
and don't
funny.
forget to sign up.
When I was in the hospital, I was teaching my dad what we learned in SI, and he was like completely confused.
Well, yeah, this is
'Cause
pretty
I was like,
hard.
I was like doing it like in the air and stuff, and he's like, "What?" He's like, "This is just regular algebra." I'm like, "Yeah." He's like, "You understand it all?" I was like, "Yeah."
Yeah, you're doing really good. Really, really good.
I'm just glad I'm getting extra study time because I don't want to do that on a test.
What do you feel about this activity where you have to?
They're probably gonna help me because I'll remember the steps on how to do them.
Yeah, I like when you guys do the lessons. When did you say you're getting a Christmas tree?
This weekend.
So exciting.